type of thing as yesterday where we have like a money situation. And one way to write this would be that we have two of the money bags. Remember we were calling them X? So on the left-hand side, Nick, what would you have? Like what does all of this represent? 2x plus 4. And on the right-hand side, you have 12. Raise your hand if that makes sense. So that's the old stuff. So I'm going to subtract 4 from both sides. And in the morning class, this is getting quicker. Is it quicker for you to know the next step there? Because basically you would, up here you would say, well, there's 4 here, so I could cancel out 4 here, which is subtracting from both sides. And on the left-hand side, then I just have the 2 x's and 8. And so these 2 money bags here represent those 8 coins. So I could break them into 2 groups and say there's 4 coins in each group, right? So the way I show that is with division. So x is equal to 4. Does that make sense? And so if I checked my work, I'd have 4 plus this 2 coins already, plus 4 plus 2 coins, that equals 12, which is the same as the right-hand side. Does that make sense? Okay. Everybody's good with that? So this is what's different. Another way to look at this. So sometimes having more than one way to solve a problem is handy. So do you see that this group is the exact same thing as this group? Okay. Well, and yeah, we're going to get there. I think you're on the right track. So if I were going to write this a different way, let's move this down. I could say there's 2 of the same groups. And in each bag, what's in each bag? Jason?
4.
Well, we don't know. It's x and 2, right? In each bag there's an x and 2 coins. So there's x plus 2 in each bag. See that? And on the right-hand side we still have 12, right? But couldn't I separate the right-hand side into 2 groups? So wouldn't I really know that one bag, which is just the x plus 2, is equal to the 6 coins? Do you see what I just did? Because there's 2 bags here and 2 groups here. I can show that with division. I can divide this by 2. And I have x plus 2 is equal to 6. And subtract 2. And I get x equals 4. I get the same answer a different way. But it's less work. So sometimes this method could be less work. Allie? X has to be 4 because we showed it 2 different ways. So let's try this idea one more time, okay? So look at this problem down here. Okay, when you look at this problem, do you see that one way to write this is 4x plus 2 equals 3, 6, 9, 12, 15, 18? You see that? Yes or no?
Oh, yes.
So could I, and I could go this way of subtracting. So if I move this over here, it would be like canceling 2 here and 2 here, right? And so I would have 4x equals 16. And then there's 4 bags here, right? So I could divide this into 4 groups. But it's a little bit of work to show it, but I could. Each group would have 4 little coins, right? It's true, they're not arranged the same, but there's still 4 groups there, right? Does that make sense? So X has to be 4 in each bag. But, Allie, I'm going to have you hold your question for a minute. I'm going to ask you to look at this a different way, because can you see even groups over here? How many do you see, Nick?
I see 2 bags of 1 coin.
2 groups of 2 bags and 1 coin. Do you see that? So 2 groups of 2x plus 1. Does that make sense? You could just, we're going to look at that too. But do you see the 2 groups there? And it's equal to 18 still. And can I break this into 2 groups? So if I just take the 18, I know that one group is equal to how many coins? One group. One group is equal to 9 coins, so I could divide by 2. I'm not finished yet though, but do you see I could do that? Because you're right, Allie, there is 2 bags, so all I know right now is that this is true. You agree with me? I don't know what's in the bag yet, but I could figure it out. We're trying to get the X part alone, right? So I'm trying to now figure out what this is, right? But we don't have 4 groups here. We only have 2 groups. They have to be the exact same kinds of groups. But you don't have 4 coins. The groups have to be the same. Do you see that? So I'm going to go ahead and solve this by subtracting 1. I have 2x equals 8. So what is x?
4.
It's 4. The same, right? Nick. You could, but you probably wouldn't because it would be more work. The whole idea is using this method if it's nicer. Sometimes it's nicer, sometimes it's not. You know what I mean? So it's just another skill. Like, for example, you could do this one. If we look at this one, how many groups do you see here? 3. So you know there's 3 groups. So in each group, there's 2 coins in 1 bag, right? Do you see what I'm doing? And it's equal to 2, 4, 6, 8, 10, 12. So can I break 12 into 3 even groups? Yeah, so when I can, it's quicker. So I know that I have x plus 2 equals 4. Isn't that nice and quick? So I have x equals 2. But if it's not nice and easy, then you maybe would use the old method. Like, look at this. Can you see there's 3 groups like this here? So there's 3 groups of x plus 1, and that's equal to 2x plus 2, 4, 6, 8, 9. That doesn't divide really nice by 3, does it? I mean, it's not like one nice number like this is it? I mean, the right-hand side, it doesn't look so easy now, does it? So when it's not so easy, how about write it as 3x plus 3? Wouldn't that be easier? And you would use last night's skill? Does that make sense? What did I do there, Nick? We're going to run out of time.
Say an alternate way to also figure it out.
Right?
You could, on the right side, you could cancel those 2 bags with 2 bags on the other side.
Right, which is this method. So this method wouldn't be, so we wouldn't use the method here. So that's the new thing added in tonight. If you had trouble solving with the variables on both sides like this, watch that video from last night. And I'll post this, and then we'll do questions tomorrow. We're not going to do anything new tomorrow. We're going to keep practicing.